Today we're going to take a look at a language model which learns to play the game of Snake, as you can see here. It is still training at Epoch 11, but it's playing it pretty well, as you can see. This is done via behavioral cloning, so we're not going to use any reinforcement learning or evolutionary algorithm. It's pretty cool. You can ask Cursor to generate this yourself. We are going to go through the process, but you can also download it from my Patreon for free. Link will be below. So while it's still training, let's actually take a look. So this is going to use a behavioral cloning approach because we didn't want to use reinforcement learning. I wanted to try something new. So for this, we create an expert algorithm. I asked Cursor to do that. A reasonably competent snake playing algorithm based on breadth first search to find path to food is implemented. That is here, expert snake player, right there. All right. And then we have a data generation process where the expert algorithm plays the game many times and its gameplay is recorded. So that is done via the generate data.py file. And when you run this, it plays and generates data for 1,000 games and saves it to LM play snake. Sorry, expert snake data.pickle file. And then we train a transformer encoder model. Trained on this recorded data, the model learns to predict the next action the expert would take given a specific game state. And then the trained transformer model can then be used to play the game. So these are the files for this. Checkpoints actually stores the best snake transformer. And we also store the checkpoints. The configuration file includes the configuration constants for the snake. The expert snake player.py, which we took a look, actually is the expert snake player, which checks if a point is within bounds and not on the snake's body. It also performs breadth first search to find the shortest path from start to target and determines the best action for the snake based on BFS pathfinding. So this is actually a good way to learn about these types of search algorithms as well. And now we have the generate data.py, which maps action to integer labels for classification. The core logic of the game is in snakegame.py. We don't render the game when actually generating the data. So this is just to the general logic for our snake game. And then we have the train.py. Once this snake data.pickle file is generated, then we actually load them and then load it and train on it. Here are some hyperparameters for our transformer model. And we also have the transformer model.py, which is the main configuration file for our model. We have 4 classes because the actions that the snake can take is up, down, left, and right. Embed dimensions is for the input tokens. That is the grid cell values. That is the map of the snake game. That is. We are using actually 8 attention heads. And we are using 6 transformer encoder layers. That means, and when we look at the 512th dimension of the feed-forward network, I believe, if I'm not mistaken, the 6 layers include these feed-forward layers, or rather maybe both of them combined. I'm actually a little hazy there. And we are using a dropout. Dropout and also another term, rate decay, is actually great to avoid overfitting scenarios. And we also have a vocabulary size, the number of unique cell values, which can be empty, can be the head, body, food, or maybe a padding if needed. So normally in a regular language model, the vocabulary size is all the tokens, can be 50, 60, 70,000 of them or more. So actually it is interesting. We are using a language model essentially, and we are defining a vocabulary as well. So this vocabulary actually is what populates this input dimensions of the grid size. So when we create this grid, we actually populate it with these tokens, so to speak, empty if it contains a head, body, food, or a padding, if just in case if needed. Yeah, there's also a README you can learn more about. There's also some utilities to actually plot the metrics. Let's take a look. You can actually see the training progress. This is the loss. Loss needs to go down and accuracy needs to come up. It's actually getting pretty good. Let's try it again. We are on Epoch 14. I am actually still training it as I'm recording this. Okay, here it is. Let's see how well it's doing. It actually learned it pretty fast. I wasn't very hopeful of this approach. I actually, if you look at my conversation here, it suggested heavily to actually use reinforcement learning or evolutionary algorithm, but we went with the expert algorithm behavioral cloning approach. So, like I said, you can download this for free from my Patreon and modify it with Cursor or your favorite IDE to your use case. Also, when you check my Patreon, consider becoming a paid member to access my 1000x Cursor course. I have 47 chapters and also my live 1000x lab meetings for my patrons. These are actually live. We do it either every Sunday or sometimes multiple times a week. Yeah, thank you for watching, and I hope you enjoyed this, and see you in the next video.